We are thrilled to have you come out and join us tonight. Thank you so much for coming. As I recall my life as a college student, I remember the difficulty of finding an open place to freely wrestle with my deep intellectual doubts and questions about the Christian faith. I'm now excited to be involved with Ratio Christi because it provides an opportunity to integrate faith, reason, and logic. I wish I could have been in such a group as a young college engineering student. Ratio Christi has been on the University of Iowa campus for about 5 years. The purpose of the student organization Ratio Christi is to equip university students and faculty with the historical, philosophical, and scientific reasons for following Jesus Christ. During the school year, we typically meet Sunday afternoons here in the IMU. We are currently discussing Exploring the God Question, which is a series of 6 30-minute videos. In it, world-renowned contributors from both sides of the argument. Our purpose in Ratio Christi is to help people become critical thinkers. Both sides of the science-God debate and unpack evidence found in the cosmos, in life and evolution, and the hidden depths of mind and consciousness. To find out times and room location for Ratio Christi, check out our Facebook page or go out and check out our table in the lobby, our resource table after the event. Also, if you'd like to go, you probably saw the advertisement up on the screen. If you'd like to go to the Intelligent Faith Conference tomorrow, a couple of speakers are actually here tonight. And you can actually get the pre-registration price of $30. It's Friday night and Saturday. And just mention that you were here tonight when you walk in and register at the Intelligent Faith Conference in Cedar Rapids. For more information on the Intelligent Faith Conference, visit our table in the back, or I think also Serve the City may be here with some flyers on it. Next up is Geneva Campus Ministry, who is co-sponsoring the event with us. Thank you.
Thank you, Jim. I'm Tom Waltice. I'm the director of Geneva Campus Ministry. Geneva's been campus ministry at the university here since 1972, and we appreciated the invitation from Ratio Christi to join with them in sponsoring this lecture. Geneva also brings lectures to campus every semester. We've done that for over 40 years. We think that's an excellent way to engage with the university and to bring Christian perspectives on serious academic and social topics in our world today. You might have seen a slide come up. We have our Geneva lecture coming up in a couple of months, the last Sunday of April, in which we're bringing a community activist and pastor from Pittsburgh to talk about hearing the overlooked, the unheard voices in our society and how we can address those. So we hope that you see that and have interest to come out on that on a Sunday afternoon, the last Sunday of April as well. Geneva, we promote ourselves when we say we are a Christian exploration at the university. That word exploring is an important word for us. We want to help people explore Christianity. Those who have questions about it, those who don't know much about it, we invite them in to interact with that. We also want Christian students to explore life and learning in light of their faith. And so we help them explore Scripture and how to read Scripture. We are also developing some new groups that are discipline-based to help people in a given discipline to look at how that engages with the Christian faith. We've just started a group up at the law school, so if there's any lawyers here or law students, we'd invite you to find out about that from us as well. We have information on the back table as well. We want to welcome you here and hope that you'll find this engaging and that you will also find other ways to engage in the various ministries. We have other ministries represented out there too from a variety of traditions, and we hope that also you will find ways to engage with them and support them too. But thank you for coming, and we'll look forward to this evening.
Hello everyone, thanks for coming out tonight. My name is Sam Kropfel, and I am a student leader with the University of Iowa's Ratio Christi movement. We are deeply honored to have Dr. Fred Skiff as our organization's advisor. Dr. Skiff graduated with a 4.0 in engineering physics from Cornell University in 1979 and then went on to receive an MA in physics in 1981, followed by a PhD in physics in 1985, both of which were from Princeton University. Dr. Skiff came to the University of Iowa in 1998 and became a professor of the Department of Physics and Astronomy in 2000. Dr. Skiff is a member of the American Physical Society Division of Plasma Physics, of which he has been elected the chair, which he has been serving in since 2012. Dr. Skiff leads the U-Iowa Fundamental Plasma Physics Skiff Research Group and has been the departmental chair for the Department of Physics and Astronomy for the last 5.5 years. Dr. Skiff has also received many awards and honors. So please give a warm welcome to Dr. Fred Skiff.
Great. Yeah, good evening. Glad to see you all here. And I'd like to thank the Ratio Christi and Geneva Campus Ministries for this event. For me, it's an opportunity to bring in a very interesting person who might otherwise be difficult to bring on campus. I received some emails telling me I should be ashamed to bring him on campus. And I hope that I'll give him a little introduction here, and I hope you'll realize that he's very worthy of being heard. And I remember when I was a graduate student at Princeton, Louis Alvarez, who was a Nobel Prize winner, was coming to campus to give a talk. Actually, he and his son had this theory on extinction of dinosaurs. And the important point is not whether or not his particular theory is correct, although I think it is still the accepted theory now. At the time, he was banned from campus. He was considered a heretic because his theory was different from the existing theory. And I thought, this is ridiculous to treat him like this. And I remember going and finding him out in the room off campus where he spoke. And I was glad there were people who gave him a chance to speak. And I remember listening to his talk and thinking, well, this is interesting. He has an interesting idea, it's worthy of being discussed. And so I'm really thankful that Ratio Christi and Geneva Campus Ministry have allowed us to host this event tonight. So without further ado, I want to introduce Bill Dembski. And actually, if you can bring up the first slide, please. So normally I wouldn't go into great length like this, but since people, I was as appalled at how Bill has been treated as I was when I was a graduate student about how Louis Alvarez was being treated. So Bill has actually 2 PhDs. I guess this is the mic right now. I can read it from here. So he has 2 PhDs and an MDiv. So he has a PhD in philosophy. He has a PhD in mathematics, and with Leo Kadanoff. Now, if you know anything about physics, Leo Kadanoff is he received just about every single prize in physics other than the Nobel Prize, and some people felt he should have gotten that. But, and so Bill has very good credentials to talk about what he talks about in his books. And so, if you could advance to the next. All right, so, and he has many awards and recognitions, which are, from reputable organizations like the National Science Foundation, and his work. In fact, the book we're going to discuss this evening is he received a book award from the Templeton Foundation, who really specialize in supporting work having to do with the interface of science and theology. So I think that his credentials are impeccable for the work he's done. And personally, why I wanted to invite him is I've read his books. I think his work is very creative, and he's an independent thinker. So next slide, please. Yeah, so 2 mentors, and actually I have a slight connection here with both of his, the connections that these gentlemen here are kind of precursors in some ways of Bill's work in his books. Leo Kadanoff on the left, as I mentioned, he's a highly acclaimed physicist from the last century. Although I think he just passed away about 4 or 5 years ago. And he's very famous for his work on what are called phase transitions and complexity. And earlier in my career, at about the same time that Kadanoff was working on problems in chaos and nonlinear dynamics, so was I. And so I had some interactions with him and was because this whole question of complexity is it's a part of it. It's not the same thing as teleology, but it's connected. And then John Wheeler, so when I was at Princeton, the professor I worked with, Tom Stix, he's well known in plasma physics, his mentor was John Wheeler. So my sort of grand mentor is John Wheeler. And Wheeler was extremely famous and had just retired when I became a graduate student there. But I got to hear him speak about this subject, and Wheeler had thought at one point you could reduce the whole world to particles, and then later in his career he thought, well, we can reduce all things to fields. And then the third phase of his intellectual life, he realized that there's something deeper, and he thought and he was struggling with interpretations of quantum mechanics, and was coming to the conclusion that information is actually more fundamental than either particles or fields. And so this is actually a precursor to the subject, really, for tonight, because that's exactly really the thesis. I mean, Bill has his own unique way, really, of formulating information theory, which I think is helpful. But in some ways, these gentlemen are precursors of his work. Next slide, please. Now, why, as a physicist, would I care about metaphysics, or why should you care about it? Well, first of all, ideas are very important because, in physics, we propose ontologies. In other words, what is the stuff of the world made of? But also, when you put forth a metaphysics, you're thinking about what things can exist. And in physics, we often encounter situations where we feel frustrated with the models that we currently have. So I have one of my favorite quotes of Michael Faraday here. He's one of I'd say, the best experimental scientists of all time. He didn't know calculus, but his experiments were so careful that he was able to understand conceptually the nature of the electromagnetic field. And he understood that the electromagnetic field, this is the field of which light is a manifestation, is not material. And the only other person I think in the 19th century who understood this was James Clerk Maxwell, who in the final edition of his book concluded you couldn't come up with a mechanical model for the electromagnetic field. And so, unfortunately, because our civilization has become attached to materialism, people concluded, well, there's no ether. But that's really a philosophically incoherent thing to say. What we have is a quantum relativistic ether, which is a weird thing. And Faraday just has his own way of saying it. He puts forward the bold idea of anti-materialism. In other words, materialism is an inadequate metaphysical picture of the world. So that's why I think that it's important to listen to ideas that go outside the box. And now, why is it so hard to do that in our present day? And so I just want to mention a couple more books just for your leisure reading. I do recommend Faraday's notes. I have them. There's several big volumes. He's an amazing experimental scientist. Next slide, please. So it actually, very shortly after Faraday retired, he was followed for a period of 30 years by a group of individuals who formed a club, actually, a dinner club, known as the X Club, and it's considering their importance in the history of science and of the Western world. It's surprising how little they're discussed, but there is a book that just came out, and I recommend Ruth Barton's book. She's an extremely good historian, in my opinion, and she gives an assessment of that period of history. And what happened basically is there were a lot of people very unhappy with the authority of the church in universities. And so they said, we got to replace it. We got to get the university out of the church out of the university and replace it with another authority, which would be, and sometimes I would call it the new religion, but now it's just called science. But it's not science as in what scientists do in their lab. It's science equals materialism. So in other words, science is a religion. And that's why people can get, instead of just behaving like regular scientists and say, let's just hear your theory, want to ban people because they're heretics. And so, unfortunately, that can happen. So this is a very interesting intellectual history. Next book, please. And of course, one of the things with materialism is that it basically leaves no place, no ontology for word. And obviously this is one reason why Christians care about it, because for a Christian, a word preceded the creation of matter. But words are important to a lot of people, and I recommend highly the essays of Marilyn Robinson from our own university here. And her analysis of materialism is profound and cogent. Next, please. So for me, I also, in studying physics, you study the organization of matter, and what's interesting to me is the organization of a text is really quite an enigmatic thing from the point of view of physics. So I have here two things. So last weekend, I was at the wedding of my son, and in a moment when we were alone together, I recited to him one of Shakespeare's sonnets that I know by heart on the left there. And then, for the fun of it, I took it and cut and pasted and then randomized the letters. Now, why would I do that? It's a strange thing that physicists do, I guess. So on the right, of course, if you look at that text, all the same letters are there. If you apply complexity measures like, if I wanted to compress this on my hard drive, it turns out that the text you can read is easier to compress, because English is not really a random use of letters, whereas on the other side, the letters are randomly dispersed. So on the right-hand side, you have a text there that has more complexity, more information from the definition, which just purely measures structure. So there's more information and more complexity, and yet the only problem is it's completely meaningless, right? And so it seems to me that the really thing that makes that block of texts, when I recited it to my son, it affected him. It functioned. It functioned in a relationship. And he responded to the text. And that's what's significant, and I think that in lots of systems, like in biology, what's significant is not that it's just complex. What's significant is that it functions, and that it actually corresponds to something. But anyway, next slide, please. These are the distinctions. So I didn't really find anybody really thinking about these things until I read the books of Bill Dembski. And so he's really, and these latter two books were done with the support from the Templeton Foundation. And without further ado, let me introduce our guest. I've left him back there too long already. Bill Dembski.
Good, thank you.
Bill. Yeah.
Thank you. Okay.
So welcome, Bill.
Nice to be here.
And so I think it'd be good to start with maybe a description of your own personal walk through this. I mean, what led you to, you were in school for a long time, doing philosophy, you did MDiv, you did mathematics. Did you have a goal? I mean, were you thinking of this project of yours with these three books from early on? How does this fit into your sort of life's work?
Let me, you're asking me in some ways to back up quite a bit, and it really takes me back to the days with Leo Kadanoff. I was working on nonlinear dynamics, chaos, trying to understand the nature of randomness, and so that was my dissertation with him. And it led me to trying to get some new research projects after I got my PhD there. And I got to reading Richard Dawkins' The Blind Watchmaker. And in that book, he will make the claim that living systems have this feature, specified complexity, that he thought it could be explained by natural selection. And I thought, as I read it, I thought, this doesn't really hold together. And so it got me thinking about applying probabilistic methods to the information problem in biology. And so one thing led to another. I got involved with a research group there that was doing work in what became the intelligent design movement. Ended up writing the design inference, where I was trying to understand how is it that we infer design? What are the features of systems that would tell us that they're the product of an intelligence? So if you're driving through southwest South Dakota and you see a rock formation that looks like Teddy Roosevelt, Abe Lincoln, etc., you know that that is the consequence of an intelligence, even if you didn't know that Gutzon Berglund spent the better part of his life dynamiting and chiseling that mountain. There's something different from that mountain face compared to the other rock formations in that area. But what is it? What are the features? And so I was trying to understand the statistical features that allow us to infer design. And it was this confluence of specification. You couldn't just have a small probability event by itself. Small probability, lots of things happen with small probability. If I throw some marbles on the ground there, the precise configuration that they take is going to be highly improbable. But the issue is if that configuration then corresponds to Pleiades or some precise, something that's specified independently, then we're going to say, well, wait a second, there's something funny going on there. One way I would illustrate this is you have an archer shooting at a large wall. The arrowhead point is very small, so it's highly improbable wherever that arrow is going to land. But if you then set a target and you keep hitting the target, then you know after a while that this is a world-class archer, that it's not just random chance. And so it's these sorts of arguments that I was looking at, but it's, so, you know, if there's going to be a convincing theory of intelligent design for biology, if we can identify intelligence within biological systems, then we need a reliable method of design detection. So that was the first book there, Design Inference. I was trying to understand that. And, you know, it was actually well received at the time, but the thing is I quickly got branded a heretic, a creationist, and, you know, my career just didn't prosper as a consequence of that. I mean, it just, but I persisted. But the thing is, the marker of intelligence, the statistical marker, also corresponded to a notion of information. The specified complexity was a type of information. And so then my research ended up going into the type of information that we see in biological systems, and then asking how can this sort of information come about. And what we found, I was working with a Baylor engineer whose expertise was computational intelligence and evolutionary computing. And what we found was a conservation principle, which really said that the information that is being output by these evolutionary search procedures always has to be balanced by input. And the input information is always going to be at least as much as what you get out. Okay, and then we proved this mathematically. We published it in IEEE journals. There was a key article was in a journal of computational intelligence and intelligence systems out of Japan. So it got into the peer-reviewed literature. The editor at Wikipedia, who controls my biography, has made sure that none of those articles end up in the Wikipedia entry. So, you know, to this day, they make sure that the very first words in my bio are that I do intelligent design and that I'm a pseudoscientist. You know, so I deal with that, but you know, but the work is there. It stands on its own merits, and I think it is borne up well. And I mean, it is a conservation principle, and what it suggests is that the information problem, as you move back, as you try to explain information, it always intensifies. It doesn't get easier. And this is exactly the opposite of what the materialist evolutionary biologist needs, which is to get complexity from simplicity. And these information arguments show that the information always gets worse. And I can illustrate this. I mean, there's some examples that I would use for this. So, for instance, let's imagine an Easter egg hunt. You got a vast field, and what can you do to try to find it? Well, let's say you've got Alice who's looking for the Easter egg, and Bob is going to give her feedback. So Alice moves to a spot, and Bob says no. She moves to another spot, Bob says no. The only time he's going to say yes is if she's right over the egg. That's a blind search, okay? If the field is extremely large, it's going to be virtually impossible to find that. Okay, it's a needle in the haystack problem. A needle in the haystack, unless you have some additional information, and it's not just frivolous that I'm saying additional information, it's mathematically precise. Unless you have additional information, you're not going to find that Easter egg. So what might Bob instead say? Well, Alice moves, Bob says warmer. She moves again, colder. She moves again, warmer, 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 hot. Yes. Okay. Now, what has happened there? Alice has gotten information. Okay. Now, the evolutionist usually just leaves it there and says, well, see, evolutionary processes work. So an evolutionary process is like Bob giving the warmer hints rather than just the yes-no blind search. But the question is, well, where did Bob get the information to give those instructions, warmer, etc.? Because he could have said warmer, colder, in ways that were random and would not have taken Alice to the Easter egg. In fact, the information could have even been negative in the sense that he could have guided her away from the Easter egg. So that information guiding, as it were, sits in a higher level search space. So where did you get the information that then allows you to guide Alice to it? And it becomes that higher order information becomes that much more intractable, informationally speaking. It becomes harder to search for the search space than the original space. If that sounds a little abstruse, here's another example. Let's imagine instead of an Easter egg hunt that Alice is searching for treasure, okay? And so blind search isn't going to get her there, but if she has a map, then the map will direct her. There'll be an X on the map, and then she'll find it, and there's the treasure. But that map, how did she get the right map? That map presumably resides in a whole library of maps, any one of which could be guiding her to different places. So how did she get the right map that then guides her to it? Okay, and so in a sense what happens is the information problem gets displaced. So instead of now accounting for how you might have gotten there just by blind search, now you've got to explain how you got that map. And then you might say, well, then there's a map that guides you through the maps. There's an index, but then you've got to search that. And the mathematics of it, and it's precise mathematics, it says that the information problem only intensifies, as you go back. And so you haven't explained anything. You haven't gotten complexity from simplicity. As you backtrack, trying to explain information, the information problem intensifies, and so you've got more information to explain as input than what you get out. And
right.
It's precise. It nails it down. I think it does, in a sense, for information theory, what like a Gödel's incompleteness does for Turing computability. But it's, so it seems to be a very significant result. It extends the no free lunch results of Walpert and McCready, and I think it's nailed things down pretty nicely. But the work hasn't really gotten that much play. So that's in my view the sad thing, because
maybe it would help the audience to have like a simplest possible definition of what information is, because the term sounds like it's from a newspaper, right? Information coming in a newspaper.
Yeah.
But of course, the mathematical concept is quite different. There's you have some sort of what you call a reference class. Mm-hmm. But is there some way of really trying to communicate that? Because that's a really crucial, your way of formulating that, I think, is really important to understanding the results.
Yeah, it's, to this day I still struggle, because I can give a definition. Information is the reduction of possibilities within a reference class. Okay,
Reduction of
possibilities.
possibilities within a
With a
reference class.
of possibilities. Okay, so
Okay, that's pretty mathematical.
That's a definition, and it entirely characterizes what Shannon did. It captures what you have with semantic information, although it's not a semantic notion. I mean, in a sense, you have to build the semantic.
Let me just try
over.
something, and you
Yeah.
can tell me if I'm getting it.
Okay.
So basically, someone here, two people communicating by radio, which goes back to Shannon, who was actually was a telephone system, and then someone says, well, George is coming to dinner, right? And it got kind of garbled there because there's loss of information, not gaining. Yeah. And then the other person says, George. Now, what is that? Could that be George or Ralph? And then they get some noise. And so there's a reference class of possibilities, which are names, right? And so basically, the more information, actually, the fewer the possibilities, right? Is that basically because you're narrowing down?
That's right. Although, by introducing noise, I mean, you've complicated things a bit because at the sender's end, it is a precise sentence, so things are very much narrowed down. Okay, right. From the entire range of possible communications, it's just that one sentence. Right. At the receiver's end, now there's this fuzz, so there's still a reduction of possibilities. It's not, whatever you're going to interpret it as, it's not that University of Iowa is going to win the Rose Bowl or something. You're not going to. That's not going to be part of it. So, but I should say a little bit. I mean, this intuition. I give you this abstract definition. So, what does that really mean? But I mean, the intuition with information as a reduction or a reduction of possibilities. Let me try to motivate that because it makes actually good intuitive sense. So if I say something like, it's raining outside, okay, I've given you information because I've reduced the space of possibilities from it's raining outside or it's not raining outside. That's, it's one or the other, and I've said it's this, not that. And so information always presupposes a negation. It's saying it's something but not something else. If you haven't ruled out anything, you're not conveying information. So if I give you a tautology, it's raining outside or it's not raining outside, I haven't conveyed anything. You could figure that out by yourself. So it's only by reducing possibilities that I'm conveying information. Okay. But the more I reduce them, if I then add, it's raining outside at 1 inch an hour, that's a heavy downpour, I've reduced things even further, okay? Now, that's just the general definition. For science, you also need to be able then to measure the information. So that with the Shannon theory, which is looking at alphanumeric characters, it's very easy to assign at least uniform probabilities, and then you can define other probabilities based on the characteristics of language. U follows Q, and whatever, if you've got, let's say you're using an English language convention. But just in general, though, in terms of calculating information, it's done in terms of probabilities. So if I tell you it's raining outside and it's in Seattle, it rains a lot in Seattle, so that's actually a pretty high probability event. Higher probabilities correspond to lower information. But if I say it's raining outside and it's the Sahara Desert, then you might say, well, it rains very infrequently in the Sahara Desert, so I've given you more information. It would be that much harder for you to figure it out. Sometimes information theorists talk about the surprisal value. But the narrower the possibilities, the more information you're getting. So that's the idea. And then you can measure that in terms of improbability. So smaller probability corresponds to more information. It becomes convenient to measure information in bits, so you usually do a transformation of probabilities in terms of a negative logarithm to the base 2. And so then you have it in terms of bits. But that's just a convention. But the underlying idea is that information increases as the probability decreases. And it makes good sense. I mean, if you think of bit strings being sent over a communication channel, each bit corresponds to a coin flip, so the more bits, the more improbable that a series of coin flips is going to capture that particular or be identical with that particular bit sequence. and that improbability then corresponds to the information, a measure of information.
So now let me transition to the book, because I do want to get to the, because what you're, the being as communion, and you can maybe give a few words about how you came to that title.
Yeah.
You're trying to get at a new metaphysics, really, and so saying that what's most fundamental in the world is not elementary particles, it's a theory of communication. And so can you talk a little bit about how you came to the title of your book, and where did this come from?
Yeah, I mean, I think it's still a good title. It captures what I wanted to do in that book. At the same time, I think with that title, I lost most of the scientific community in terms of trying to argue for the primacy of information as what we are studying in science. And so it was published in a Science and Religion series with Ashgate Publishers, and I stuck with the title because out of obligation to the Templeton Foundation, which had funded this book project. And essentially 2 books came out of it. There was a trilogy that you put up there, Design Inference. The middle book was No Free Lunch, and where I was applying these design inferential methods to biology and then also developing some of this information theoretic apparatus. But then in the Being as Communion, that came after all this work with Bob Marks and the Baylor Group on conservation of information. And that really, I think, gave me the confidence that information really was something fundamental, that I wasn't just blowing smoke. But then I wrote the book, and so I was arguing for this more radical thesis. I mean, you don't need information to be the fundamental stuff of reality, of a physical or the science, for the sort of critique that I was making of evolutionary search to hold up. Conservation of information applies to information, whatever the reach of information is. In this book, I was arguing that it's information all the way down until you get to some, intelligence that creates the information, or it could just be, or conceivably it could just be it's all information. There's nothing beyond that. But that seems to me a less compelling thesis, and we can talk about that. But so the idea, though, was to argue that information really is the fundamental stuff of science, and I think for that it wasn't just these sorts of evolutionary search arguments. It was more thinking about what are we doing in science? And it seems in science what we're always looking at are patterns, characteristic patterns that arise out of interactions. I mean, it could be as simple as an old Galileo experiment dropping, weights from a Tower of Pisa or something. There's certain patterns of interaction, with the release and how the weights drop. But it seems that what we're studying ultimately are these patterns, and it's not that the matter that we're attributing to these things is, as it were, conceptually downstream. And so I thought this was really exemplified to me in 2 more recent discoveries. One was the Higgs boson, which at CERN a few years ago. And what is it that convinced the scientists that they had this Higgs boson? It wasn't that they grabbed something and said, "Oh, here is the Higgs boson." What they did was they did this experiment where they used this collider, energized certain particles, but then they got this characteristic scatter. The theory predicted that under certain conditions, a certain type of pattern would emerge, which was then, and there was this image that was just broadcast throughout the world, and you've got some slides that I sent you, and one of those is that image. And it was that characteristic pattern, this signature of the Higgs boson, that convinced us of its reality. But that means, in a sense, it seems to me that the pattern is more fundamental than, that thing behind it. And so it seemed to me that it's really the patterns of interaction that are the fundamental thing that we study, and not some sort of matter that's just matter without any characteristics. It always comes with characteristics. It always has these informational qualities, and we only understand things in terms of how they interact with other things. And that also speaks to this, this fancy term, relational ontology, which just means that things are real insofar as they interact with other things. So it's not that a thing can be real just in isolation from anything else. And it seems that that's also characteristic of science, that we're constantly interacting or seeing things interact, and it's in the interaction, the patterns that emerge from that the reality of the thing emerges. So in a sense, to say that there's still matter underneath that seems superfluous. What we have are these patterns, and things are the potential to generate patterns in interaction with other things. It seems that that's what's fundamental. So that's the sort of intuition.
A conceptual framework. That's very much. Yeah. That's very close to what John Wheeler.
Yeah, it is. Although I think he was talking though in terms of apparatus and the thing you're studying, and then this it from bit where you're answering yes/no questions. And I think if you, it's certainly implicit there. I think as I read his stuff, though, it seems that the apparatus takes a primacy, which then draws away from the it from bit conclusion that he's after. And so I think maybe, it's very close,
Yeah, I mean, he was struggling with what was called the measurement, or is called the measurement problem in quantum mechanics.
Yeah. So, so I'm not sure, if I have a claim to fame in this, it's more, I think, on the conservation of information front, evolutionary search, showing that the information problem intensifies as you go back. The sort of metaphysics of information, I think it's very much in line with things that John Wheeler, Paul Davies, and others, Rolf Landauer perhaps, and others were promoting, and so there's, but for me, it's compelling that and it's there are lots of examples I consider in the book for how information seems to be fundamental, and the hypothesis of matter, as it were, ends up there's reason to think that it's a myth, that it's something, that it's an explanatory device that we really don't need, that all we really need is information. And then that also does raise the question of what is the ultimate source of this information, and in our own human experience, we have information. We live in an information age, but ultimately, especially if we think of it as information on the internet or what we exchange, there's always an intelligence that generates the information. And then this is a theme, that I've certainly been pressing, and others, that the ultimate source of information is intelligence. We actually have good empirical evidence for that, and namely ourselves as information creators. So then, in terms of ontology, fundamental reality, it's not information. Information is the fundamental stuff for science, but ultimately, in terms of metaphysics, then it's intelligence that creates information, and then information becomes the stuff that we study in science. So that's, now do you need to go to an intelligence? And the question is, who or what is this intelligence? Well, if you're here at a Ratio Christi sponsored meeting, so it's, it's the big G as far as we're concerned, God, but, I think there are other ways one can take it, there are other metaphysical positions. But for me, it's compelling, and it's also consistent with my own Christian worldview. So it hangs together in a way that's convincing for me.
Yeah, I think they're somehow getting at. So in mathematical physics, there was a time when people thought, there's going to be only one mathematically possible string theory, and therefore we'll be able to say that there's no information or anything in the universe. It just had to be. It goes back to sort of Ayn Rand, her philosophical what was called objectivism. That there was only one kind of way things could be. And as time has gone on, I think people have realized, and for me, I knew this had to fail based on Gödel's incompleteness theorem. Yeah. But at least it seemed to me it was clear it would fail because of that. Because, mathematics, it seems to me, is limited only by the human imagination for us. I mean, it's a human activity, mathematics. And so you're left with, well, then which mathematics should we use? I mean, why is it, corresponding to reality with all these? I mean, so we have what we call the standard model. Take a concrete example with all these different particles. But what people would like to think is, well, that's the only way it could have been. And, for a while there, they thought we could just generate the whole thing from making no assumptions, which, seems kind of crazy, but people were hoping for that. Yeah. Now, it's, I think, pretty clear that there seems to be an uncountable infinity of string theories. And so this gets back to what you're saying. What's really fundamental is, well, what are the rules? And the rules are ruling out possibilities, right? If I understand your definition. So it's basically behind all of the created order, there is a decision that's been made, an information theoretic decision, that these are the possibilities and not others. Because a priori, you could say the universe could be any way that you can imagine. If you have a limited imagination, you could say, well, it could only be this way, right? But in fact, it could be. So information consists in. Am I going down the wrong road here? I see you.
No, I'm just looking at this because it seems to me that anybody who reflects has to think that there's plenty of contingency in the world. Should I put on my red socks or my black socks? I mean, there are all sorts of ways the world could be different. So I think just about anybody would.
But I think. Doesn't materialism, though, end up basically all, everything's just a machine, right? Or maybe a semi-random machine.
If you got quantum mechanics in there as well, I mean, unless you're going to go with some sort of Everett many worlds where, this constant world splitting and everything is deterministic in that sense. But that just seems to me also, just embraces all sorts of unknowns and things that you can't really confirm. But if you admit contingency, that the world could be different, then whatever fundamental theory there is has to allow for that, which means that there has to be a lot of free play, a lot of degrees of freedom in the theory. Otherwise, things can only play themselves out in one way, unless you want to say everything is determined down to the last, detail. The mole on your nose had to be the way it is from all eternity. It was going to play itself out that way, and it was embedded in the laws of physics right from the start. That just seems crazy. How are you going to justify it? And the fact is, we don't have this perfect theory of everything that specifies everything down to the last detail. So actually, I think it's probably much more in line with an information theoretic vision, which is that we're going to use different theories to try to grasp aspects of this world, and we may keep expanding and having more powerful theories, but maybe we'll never get a theory of everything, and that's all right, and it may just be that things are too complicated, that they don't admit the sort of theory of everything that is the materialist's pipe dream.
Yeah, I mean, even as a student, what bothered me was that if I'm nothing but a bag of chemicals, why should my thoughts correspond to the truth or error? They're just going to be the solution of a partial differential equation, and my thoughts are irrelevant. And that would, in other words, it's a theory which destroys itself.
Yeah, that's a line that Alvin Plantinga, C.S. Lewis has taken, and I find it compelling. I know that some biologists have argued, well, we've been selected for truth, but even that isn't convincing because natural selection puts a premium on survival and reproduction. It does not put a premium on truth necessarily. If you live a good delusion that keeps you keeps you functional, keeps you alive, surviving, and getting your genes to the next generation. That's all that's necessary on that theory.
Yeah. Well, I'm wondering if we should open this up for questions. I think one of the most interesting parts of events like this is to open it up to questions, and that if hopefully the audience will have had some time to think about it. We've hopefully primed the pump for some thoughts. I don't know, Jim, I wasn't told exactly how long or what we would do, but I want to make sure that we leave time for questions.
My vision isn't all that great as it is, and with these lights,
I can't see a thing.
So that would explain.
We have someone with a microphone. Great. Yeah. And so we can't see anything, but if
why don't you come on up?
This is a little better.
Just come up to the front, and
or you could bring. It might be intimidating. You can.
Up here and
here's Arnie.
Here, so you can see.
How do you make the leap to?
There you go.
Is it on?
Yes.
How do you make the leap to a personal, historic Jesus and a God who cares?
You're not going to get there from intelligent design. I mean, I think the best you're going to do is see marks of intelligence, and you can go several ways. I mean, because there's a lot that I think is awe-inspiring, jaw-dropping, but there's also a lot of just very nasty stuff. I mean, you compare William Paley to Charles Darwin. William Paley saw the world as largely an English garden where things were very pleasant. Charles Darwin took his voyage on the Beagle and saw examples of parasitism and other things and thought that this was a pretty brutal world. So I think you're going to have to look beyond just the science. I think you're going to need to be informed by theology, and and there's standard theodicies. I personally find the Augustinian one compelling, that God allows evil, both moral and natural evil, because of a greater good that is going to come out of that. But that requires also faith, because when you're in the midst of it and the throes of evil, I mean, Jesus himself talks about that because iniquity shall abound, the love of many shall wax cold. There's a wearing effect of evil on the human soul, and then people are going to be less inclined often to maintain that faith that will look to the goodness of God through the misery of this life. And I speak with some experience, not as much as I might. I think one thing that has given me a lot of solace is the example of Christian martyrs in the communist regimes of Romania and Russia. Solzhenitsyn in particular, who bore up against tremendous cruelty. But I think it's going to take more of a personal narrative. It's going to take the resources of theology rather than a scientific inquiry to get to where you're pointing.
Are there other questions, maybe?
Are you familiar with Laplace's demon?
I'm sorry?
Are you familiar with Laplace's demon? Essentially that knowing the exact position and origin of everything can be used to determine something in the far future.
Laplace's demon.
You mean?
Yes.
Yeah, Laplace.
Yeah. Sorry,
yes.
I've only read about it.
Okay, yeah.
So assuming that a single entity like a god could create the world and then determine it, wouldn't that just lead to an endless creators of the creator? And how can you reconcile that with information, I guess?
Well, I mean, Laplace was a thoroughgoing determinist there. It's funny also because he did fundamental work in probability, but he saw probability as a matter of human ignorance. So we use probabilities to try to cover or make the best sense we can out of things. But Laplace's demon, the idea was if at a given time slice in history you could know the exact positions and momenta of all particles, then you could perfectly predict the future as well as retrodict the past simply using Newtonian physics, essentially. And it's a interesting vision, but I mean, it also depends on a science that we've largely discarded and discredited. I mean, you know, we deal now with the quantum mechanics that allows for, it seems, some sort of fundamental randomness. So the sort of predictability or predictiveness and retrodictiveness, and I don't think any scientist would hold to that anymore. So in a sense, I think the quantum world allows for, if you're a theist, I mean, it seems to allow plenty of room for maneuver of the deity, you know. But even within a strictly deterministic world, it seems that there's still ways you can allow for actual human freedom. I mean, it's a sort of argument that John Ehrman at Pitt would make in his primer on determinism, where basically, well, yeah, actually, let me just leave that aside. But I mean, there's a Leibnizian type argument that you can make where basically, even in a deterministic world, God can coordinate what happens in the deterministic world so that our freedom is concursive with it. So in a sense, what happens deterministically is in response to our free actions. And so God determines the world in a way that where the determinism is logically downstream from our free will. There's a lot more to be said there. I mean, I develop it briefly in the Being as Communion, but it's so even determinism doesn't necessarily stop an argument from free will. It's counterintuitive, but there are lots of things going on there. So thank you. I probably should leave it there.
Thank you. Actually, I'd like to chime in one little thing.
Please.
Well, the other thing is that even, of course, it's true what Bill's saying about now we have the quantum theory. But actually, it's interesting, when you look at the history of science, time and time again, people get to a situation, they say, well, what's happening in my laboratory is impossible. And then they suddenly realize, eventually, that there's another way of looking at things. And so actually, it's true of what he's saying, of course, that even within a deterministic universe, but actually even within the classical physics, we have no proof of the information closure of the universe, that there's no way of information coming in. And you might say, well, then wouldn't there be a lack of conservation of energy? And that's not true. So the key ingredient, what's called chaos theory, are what are things called unstable fixed points. And the simple explanation is take a pencil and set it right on its tip. Now, which way is it going to fall? Well, if you've balanced it perfectly, with no input of energy, it could either go this way or that way, because it's at a point where it's infinitesimally sensitive to just being nicked, right? And so basically, and since it turns out the chaotic systems are generic, the universe is filled with them, even under classical physics, which we know now it's even more complicated under quantum theory, but the universe is not necessarily closed. There's no, and so it's just our minds which may be closed. But, I think, theologically, I think that God has more ways of doing things than we understand.
Thank you.
Hi. First, an apology. I have one deaf ear, and the other one seems to act as a filter that mostly filters out information. So if I didn't grasp everything you say, I want to apologize. I want to apologize in advance. I'm trying to get a fix on the way you understand information. So I'm imagining a simple device like a thermostat, let's say. The good old bimetallic strip in there, but I don't know that. And all I get to see is a needle that sort of oscillates, between two extremes in a way that's more or less regular, though maybe not fully regular. And presumably, I've got a pattern. So I've got some information. I've excluded lots of, in fact, perhaps not innumerably, infinitely many things that needle could do that it isn't doing, right? I don't have very much information. And of course, if I'm curious, what I'd like to know is what underlies the pattern. And asking that question is asking a question about causation. Because we think that causation is somehow what makes things tick the way they do. And so it seems to me the question about information must be very entangled with questions about the metaphysics of causation. And that's, of course, a very contested topic, as I'm sure you know. Hume thought that causation was nothing more than such patterns, and very few people, relatively few people now think that that's an adequate account of causation. But it's also a big question whether one can imagine a world that was just made of prime matter, Aristotelian prime matter, without any characteristics at all. And if not, what the constraints on that might be. And I'm curious whether you think that the range of possibilities there is greater than one. That is to say, is there the possibility that a theory of everything could be any one from a large range of options, or any range of options? Or might that be something that's actually nailed down in the very heart of the metaphysics of causation? And conversely, do you think that it would be possible for there to be a world that had no patterns, no regularity at all?
Well, let me start with the last thing. A world with no patterns, no regularities. If you go with a type of David Lewis, self-contained, self-consistent world, he was a philosopher at Princeton, there may be such a world. It's certainly not the world that we inhabit, and a world with no patterns is a world with no science. So, I think you'd have to reconcile yourself to that. So, you raise an interesting point about causality. Let me jump back to the earlier, first thing you brought up about the thermostat. So there's going to be this pattern of movement. If it's in response to heat and cold, so it's adjusting and setting, puts the AC on when it's too hot, puts the heater on when it's too cold. So you're going to have a very regular pattern there. There may not be much contingency or different possibilities possible because it's a deterministic sort of causal structure that's underlying that. And it's interesting, I mentioned conservation of information, and I said the information problem only intensifies as you try to explain an information output in terms of prior information input. In a sense, conservation of information would mean that you have exactly as much input as you have output. The theory that I'm proposing says, well, you might have more. But it's interesting, Peter Medawar, who was a biologist who first introduced the term conservation of information, did it in terms of deterministic causal structures, where the information output is exactly the same as what's input. And so, in a sense, I would say under the circumstances you're describing it's if you've got a causal structure in which there isn't contingency, it's just this needle is going to operate in exact proportion with what's going on with temperature changes, then in a sense the information may be zero there because it's entirely determined. And if something is entirely determined, it has to be the way it is. There's no, it's probability 1, so information 0. So it's consistent, in a sense. necessity, things have to be the way they are, collapse probabilities to 0 and 1, and thus information becomes either infinite or 0. So finally, I'm not sure I'm answering all your questions, but you raised the issue of theories of everything. I'm not sure we have a reference class of theories which would, reference class of theories of everything, which then where we can say, okay, here we've got at least a candidate space of theories that could account for everything. I'm not sure if, do string theories, superstring theories, brains, or whatever,
wouldn't you think that, the way I would look at this is Gödel's incompleteness theorem. There was this, Whitehead and Russell had this idea to unify all of mathematics, in which case you could conceive of defining such a space and delimiting it. But given Gödel's incompleteness theorem, you cannot do that. So it seems to me that any such theory would have to be incomplete almost by nature, unless you can find a way to refute the nature of mathematics.
Yeah, no, it's an interesting point. I guess for me, it's just more of a practical question. We don't even have such a space at this point, No. But if we did potentially, then I think there are questions of self-consistency and provability that Gödel raises, which is that the sorts of mathematics that may be at stake may be things that we cannot determine. That are. That there's an incompleteness there, which may then always work against this being a theory of everything because we can't justify it mathematically. And it seems that a mathematical justification is going to have to be logically upstream from then any claim that we've actually got a theory of everything. So that's,
Yeah, of course, enthusiasms for various theories come and go, but as it stands right now, I think people are sort of pretty discouraged about the idea of finding a unique theory that just had to be true, that you could try to make such an argument. There's just it doesn't appear to be the case.
I have a question. Do either of you're both mathematicians, and I'm an orthodontist in training. And I'm looking for anybody who, in mathematics, is studying in the world about the mathematics that Albert Einstein used from 1905 to 1915 to describe his general theory of relativity.
Over to you, Fred.
No, well, so I'm not sure, so differential geometry. So it was thought, for a long time that, although, maybe it wasn't. If you go back to Euclid, all right, he said there's no royal road to geometry. And there was a thought, well, there's this annoying postulate that, that parallel lines don't intersect. And they just thought, maybe that should be unnecessary to say that parallel lines don't intersect. Well, it turns out it depends on your geometry. If you're in flat space, parallel lines don't intersect. But then there's a mathematician by the name of Riemann who discovered, space doesn't have to be flat. And, for example, if you're on a sphere, which is not flat, parallel lines, which are parallel at the equator, intersect at the poles, right? And so then it became clear that, and so Einstein basically said, isn't it funny we define mass in two different ways? There's the inertial mass, right? The inertia, so something in motion tends to stay in motion. That's a basic physics fact. And then there's the fact that gravity is related to mass. And he thought there shouldn't be two different definitions. They must be the same thing somehow. That was the essence of it. And then he said, look, when you're on a Ferris wheel or on a playground thing and you're spinning around, you feel force on you. We call this centripetal force. But he said it's a phony force. It's because you're not in what's called an inertial frame. So inertial frame is one where you're not spinning around in circles, you're either at rest or you're in constant state of motion, like a straight line. And so Einstein, in his inimitable way, basically said, is there a way to make these two kinds of mass really just the same thing? So there's really gravity isn't really a force per se, it's just the fact that you're not in flat space. It's just like you're on the merry-go-round and you didn't realize it. And so his theory says that, and this is where what's called differential geometry, that's the mathematics, and that you basically say, well, we're not actually, it appears pretty flat, but if you had a very, 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 very precise instrument, you would find that triangles here on Earth the angles don't add up to 180. And you would actually be able to infer from that the mass of the Earth, because it's making space not flat, right? So adding up to 180 is what happens in flat space. Well, what if you're not in flat space? Well, one of the consequences that Einstein worked out, and it would take me a chalkboard and quite a bit of time to work out the details for you, but basically, if you're not in flat space, you're going to feel this gravitational force. And why is it not? And so it's the mass which is actually bending space. Was that your question? I hope I did.
Well, more or less. Yeah.
But there is, so what happens in so the interesting thing, and I said mathematics is limited by the imagination. What we do in physics is, when we come up against some conundrum, we invent the mathematics we need to solve it. And then we puzzle over this. And one of my professors at Princeton, Eugene Wigner, who was one of the founders of the quantum theory, he was always just astounded. And he thought it was a spiritual thing. Why does the mathematics, which is just some invention of our brains, have anything to do with reality? And it's a deep question, which he thought was, in the end, he wrote a little article on this. He said, in the end, it's a gift. He thought it was a gift of God that the world was intelligible to us at all. And so I'll leave you with that.
Thank you.
Hello. I hope I don't get this incorrectly, but I believe you referred to the term biological search in the beginning?
Evolutionary search.
Evolutionary search, okay. So I was thinking about it, and it can be easily explained by natural selection. And to kind of use your example with Bob and Alice, if you have Alice in that field and she needs the Easter egg to survive, well, in this case, we're talking about Alice and her kids and grandkids and thousands of generations. And after enough time, if there's an Easter egg in the northwest corner of the field, they will know where that resource is, so they no longer need Bob, correct? So how did we make that jump from needing Bob to guide them as a source of the information? That information is being passed in their DNA. It's information, like you said, but it no longer requires a source, correct? So how did we make the jump to needing a source of that information when it's being passed?
So what you're saying is, why not just do the brute force search, I guess is what he's saying.
Well, yeah, we can, one approach I could take to respond is, well, where do we get the genes, the DNA in the first place? Origin of life is not a Darwinian problem. Origin of life is a problem often characterized in terms of what's called chemical evolution. You don't have selection even working for you. And the search problems that you face there, they get cashed out in terms of probabilities. And if the probabilities are too small, then it becomes implausible to think that it happened by chance. And this, certainly with the origin of life. We can talk about what happens when we're actually dealing with biological evolution. But, I think we all have a sense of what's within the reach of chance, what's outside the reach of chance. And I think, the way you characterize that field, it's like maybe, if we've got 1 million people on the mall in Washington, give everybody a coin, And everybody's standing, everybody flips. If they flip heads, they stay standing. They flip tails, they sit down. After the first trial, about 500,000 will be standing. Second time around, about 250,000. Third time, 125,000. On average, after 20 flips, one person will be standing. Okay, that's impressive. You've seen 20 heads in a row. Okay, that's doable given the sorts of probabilistic resources you have there. But the thing is, it's very easy for biology to exceed the probabilistic resources of the universe. If we said, flip 100 heads in a row, that's beyond the resources of all humans flipping coins, doing nothing other than flipping coins throughout the history of the human race. And I think those are the sorts of probabilities we're dealing with. So when I'm talking needle in the haystack, it's not just that there's a field where by blind search or even some sort of help by Bob, you're going to be able to find that treasure. It's this much more radical sort of improbability that we're dealing with. And so but the devil's in the details there, because, you listen to somebody like a Richard Dawkins or Ken Miller at Brown or others, and they're going to say, yeah, give me replication, natural selection, heredity, random variation, and we can get everything. And this is where I would say, no, you need additional information, and this information needs to be part of the evolutionary search. You're leaving it out, and it means that you're not going to generate the sort of biological information that you see. Made that argument in detail, but there's a lot there. So I can refer you. One place is that book, No Free Lunch, but I think probably even better is some of the articles at evoinfo.org, Evolutionary Informatics Lab, and there's one in particular, Darwin's Information Problem, or I can look it up. So if you want to talk afterwards, if you want a reference, I can give that to you.
I have a sort of a perspective on this that gives it. So the thing is that if biology were a single variable, and often when we talk about the evolution of traits, people focus, and it seemed scientific to focus on one thing, one trait. And then if you do that, then the probabilities seem manageable, because you can do what's called a random walk in one dimension. The problem is that biological systems inherently, so this goes back to von Neumann, the famous mathematician, who said, well, what would be the simplest kind of robot you could build that would be living, in other words, could do functions that like living things do? And he came up with something on the order of you'd need at least 10,000 pieces to this machine, something like that. And actually that's not too far from, say, the simplest living organisms, the number of, variables. The problem is that when you have 10,000 variables, say, and that's the simplest case, the simplest organism, that 10,000 goes in the exponent mathematically. So in other words, does it live or die? Is the cell better at moving along? Well, that's one problem, but what about all the endoplasmic reticulum, and what about all these other parameters? They're all changing all the time, at the same time, in a noisy environment. And so when you look at the number of variables, what you find is that you need something on the order of 10 to the 10,000 generations. Well, look at the age of the universe. 1 billion is only 10 to the 9. And if you understand about mathematics, 10 to the 9 is essentially nothing compared to 10 to the 10,000. It's, powers of 10 in the exponent. And so that's, we're talking about a serious problem. And this has been known. When I first went to Cornell as an undergraduate, I had been raised as a materialist. I mean, I wasn't, raised in a Christian home. And I went to the library and wanted to find out about this mathematical theory of Darwinism. And there was a conference that took place in the 1970s. Mathematicians, it wasn't a Christian conference or anything like this. It was just a conference of mathematicians looking at Darwinism, and they concluded it doesn't work. And so they said, well, we just don't know enough. But none of those problems has been addressed.
This was I think the Wistar Symposium is what you're referring to.
Yeah, right.
I think it was around 1966, 67.
And so there's to say that there's a mathematical problem doesn't mean the whole thing's junk. In physics, we have problems, mathematical problems, and we say, if, for example, if you take the quantum theory and general relativity and put them together, you get mathematical problems that we don't know how to solve. So it doesn't mean the whole thing's wrong, but it means you have to admit there's a serious issue there. And that's what we do. We tell our students, this could be your big chance to make it big. Solve that problem between gravity, understanding Einstein's theory, and quantum mechanics.
One tidbit perhaps to add here. It's I think often we think of the universe as being so huge, and I remember Carl Sagan, he would intone billions and billions as though that was a lot, and yet the universe actually seems to be in some ways a pretty small place, at least to by chance generate the sorts of complexities that we see in biology. So there are a number of ways of getting a handle on what we might call the probabilistic resources of the universe. One is to ask how much computation is possible in the known physical universe, so the observable universe. And Seth Lloyd, a quantum computational theorist at MIT, has estimated it to be 10 to the 120 steps. That's the 10 to the 120 is the most computation you can get. The thing is, something like 10 to the 120 doesn't even get close to the number of possibilities of a small protein. It's a protein with 20 possibilities, and each amino acid plays 100 in length is going to exceed that. So biology very quickly outstrips the sort of computational resources of the universe given by this 10 to the 120. So it's kind of a neat number that, and you think even about your own computer. A supercomputer these days I think is working at petaflops, and so if you run that for a full year, you may be looking at 10 to the 30 or something. I don't know, I need to do the calculation, but you're not even getting close to that. So all the computation that we're all doing on our laptops, on the cloud servers and whatever is not even getting close to that. So it's so there's the sorts of improbabilities, information problems that we face in biology far outstrip what the computational resources of the universe.
Hi, I want to thank you for your conversation tonight. I really enjoyed it. I learned a lot, and it left me with a lot of good questions. I'm a humanist. I'm a professor in the English department here. And so the question that I want to hear you both reflect on is a question I think that's important for Ratio Christi as an organization, and is important for us if we try to think interdisciplinarily at all in the university setting, and that is, how do you imagine the sort of reason that you're using in information theory, and what is the place or the limited role of that reason into human being? So, when we talk about having a theory of everything, in a sense, right? We're imagining that everything is theorizable. And in information theory, we're imagining, that everything is informative. At the end of the day, I think the theological question is love information? And I don't think from a Christian theological perspective that that's necessarily true. So that was my line of thinking while you were talking. And so I guess I just want to hear you express your own idea about the role, what kind of reason, observational reason, calculative reason you're using, and does that account for the whole of what it is to be human, and what other human faculties are there that are, and how do they relate to this reasoning capacity that we're working with solely here tonight as one facet, I would say, of human beings. I'll sit down and just discuss that.
No, that's good. My wife's a literature person, so the sort of stuff I'm talking about here doesn't really do much for her. And that's just fine. And I know we've talked about a theory of everything. I'm not a fan of a theory of everything. I don't think such a thing exists. And if so I'm not. I'm responding to it rather than advocating it. So it seems to me that life is very rich, and I described information as ultimately being consequence of intelligence, but intelligence, we're intelligent beings, but that includes a whole emotional life. I mean, there's all, the whole richness of what we are as humans. And I don't think information theory captures much, if anything, of that. So if anything, I'd want to say, a lot of my work on information theory has been to try to understand certain aspects of science and also to take a stand, try to refute some of the materialism that I see. But I don't see anything in what I'm saying as a challenge to a more humanistic understanding of the world. I mean, I know humanism is used sometimes in an atheistic sense, but I think of humanism in a sense of, what our humanity has intrinsic value. It has certain characteristics, love, beauty, all these things that we value. It seems that, I certainly want to allow a big place for that. And it seems to me, if anything, a materialistic worldview undermines conception of our humanity. I think we see it in an extreme form with some of the strong AI people who want to say the singularity is near. We're going to get ready to upload ourselves onto computers, and good riddance to our wetware. Let's get ourselves, fully computationalized. And to me, that's just a profanation. I think it doesn't. I don't see us as being machines. I don't see that sort of vision as enriching human life. I think it's very destructive, in fact. So, I leave it there.
Well, I was going to just say that there's nothing in physics. In fact, physics really suggests that there's more in heaven and earth ratio than are dreamt of in your philosophies, and to quote Shakespeare. But that there's no, conceivable even proof of closure. So I think if we know anything, we know that we're conscious. Because if we weren't conscious, then we wouldn't know anything. And that means that there's more to the human spirit than materialism. Materialism suggests that you only think you're conscious, but you're not really. I've never found that very convincing. I don't know if are we out? How are we doing on time? We have to.
We're at 8 o'clock. Why don't we take another question?
Okay. Yeah, I can stay as long as people want. But let's maybe just take one more and.
Hi. I don't have any information about religion so I'm a civil engineer, so you can see how far off I am from these topics, but how do you place, I understand your concept of trying to explain God in some way, putting it simplistic, but how do you define Christianity or Islam or any type of religion in this type of thinking? As in, so is that a kind of information that is leading us to the so-called truth, whatever you're defining it, or being as humans and how we're created, or is that some kind of a story that was developed for better understanding and guiding people? I don't know if I can say what I'm asking, but God and religious, I'm asking about the religious part, because I believe you're Christian, and I know Muslim people, I know Christian people, and at the end, they somehow go to the same, it's not a point, maybe it's a sphere of concept, but that path of going to that, do you define it as an information, or how do you define it?
Well, let me jump in here. I think you said explaining the religion. And I don't think that's what I'm trying to do with this information theoretic approach. I see it more as a ground clearing operation, theologically speaking, because you've got a very entrenched materialistic worldview that's throughout the sciences. And this information theoretic perspective, it seems to me, undermines that, and is also of an inherent value in understanding the world. I mean, I think these ideas of conservation of information are very useful for understanding evolutionary search and trying to make sense of the creative power of natural selection, for instance, and showing that it's actually quite minimal. So there's some intrinsic scientific questions, but I think often there's the sense of, well, this is a science versus religion. So you got the materialists, they're doing science, and then you've got these crazy intelligent design people that are doing religion. And I want to say, no, it's a science versus science question that we're considering. And yet the science does seem to it can open the door for religious faith, or it can try to shut it. So you have somebody like Stephen Jay Gould, which is that ever since Darwin we know that we were not created in the image of a benevolent God. So that's a consequence that he takes, a religious consequence that he takes from evolutionary theory. So I would flip it around. I mean, an information theoretic perspective seems to open the door to theism, broadly construed. But the precise form of that theism, it seems needs to be then worked out on theological grounds. So, I mean, I get emails periodically from Iran, from Muslim believers. I've been invited, I don't know how many times, to Turkey to speak to an intelligent design group there. So I've spoken at the Oxford Center for Hindu Studies. So I mean, these are not traditional theists in the West, in the Christian mold, but they were very open to intelligent design. I would say any religious movement, system of thought that sees teleology or purpose in the universe as a fundamental thing is going to be open to intelligent design. But it's they're conceptually different. I mean, and again, it's not that intelligent design is trying to get theological mileage per se. I see it much more as a ground clearing operation, just clearing away the rubble, the bad thinking that says we are material beings, all there is matter, there's nothing beyond that, and so just get used to it, and therefore Christianity, Islam, Hinduism, all these other theistic, quasi-theistic options are non-starters. And I would say no. I mean, materialism fails on its own terms. There are good reasons to think that the science, as Fred has been hammering, that it's an open universe. God, spirits, whatever can get in there. There's nothing about science that shows that supernatural influence is impossible. And so it's opening the door. I think that's what I see theologically we're doing. And that's one reason also why intelligent design is not very popular with certain, in fact, with much of what goes by creationism these days, because creationists, when the term is used, it tends to be a young earth form of creationism, taking the Bible very literally, that it's 6 literal 24-hour days in which the earth was created. And intelligent design is not giving credence to that. It's saying, there are lots of theological possibilities, and the creationists would want something that's much more in support of what they're doing, and it's not enough for them just to say, well, intelligent design is compatible with what we're doing. They want more proof positive, and so even though 15 years ago I found that creationists tended to be favorable to intelligent design, I find that much less so these days. So.
Thank you very much. I just read your book, Dr. Dembski. I spent the last 2 weeks just plowing through it, and I like how you ended it. I wonder if you could end this evening, and I don't know if you guys can stick around just for a little bit if somebody wants to ask a private question, but you talk about God the golfer. And I wonder if you could mention that. I know nobody has scored an 18 on an 18-hole golf course, but could you maybe just articulate Oh,
okay. Well, I mean, this is the closing metaphor in my my book, and it's I mean, there's a lot at play there, but there's, you know, we think of physical reality, but there are also social realities. So you stand before a preacher and he declares you man and wife, you know, husband and wife. In that declaration, something becomes real. A social reality is formed. Money is a social reality. So there are all these sorts of social realities. And so an argument I make at the end there is that, in a sense, if God has created everything, then the world becomes a social reality of God. Okay? So that's a point I make. But then I illustrate that by saying, okay, let's imagine that God is a golfer. Okay? So, you know, you could have where God basically, you know, he'll hit the ball, but then cause it, you know, cause a wind to blow, cause a bald eagle to grab the ball and drop it into the hole. And that's really not legitimate, right? I mean, he's not really playing golf. But it could be that he plays by the rules. So he's going to be limited in terms of, you know, how far he can smack that ball, because if he's using standard golf clubs, you can only hit it so hard before the golf club is going to buckle or the ball is going to disintegrate by hitting it too hard. And so what then allows God to be the ideal golfer? And it is then the information that he is, as it were, able to impart to the ball, knowing exactly how to hit it, how it will fly, and then how it will go, ideally make it a hole-in-one. Now, if the golf course is such that instead of the hole being several hundred yards from the golfer, instead is several miles, then existing golf clubs and golf balls, even God is not going to be able to get a hole-in-one. But the golf example, it illustrates social realities, physical realities. The golf course is manicured, but you've got nature that's working there. And there's just a lot of themes in the book that I'm able to tie together with that metaphor. And just the idea of aiming a ball, you know, there's this directed energy. It's information that's being imparted, and so the example illustrates that. So thank you. I mean, but there's a lot there, and I'm not sure I can.
It's a great book. If you get a chance, pick it up, read it. Yeah. It's a wonderful book. I think you'll really enjoy it. You'll get a lot out of it. Is there any final comments here?
Well, there's one last thing. I did promise the one.
Oh, I think you came off.
That's all right. I'll hold it like this. Yeah, so I did get some emails that said I shouldn't be inviting Bill here, but and I said, well, I'll make sure to make the disclaimer that the views expressed here are not necessarily those of the Department of Physics and Astronomy or of the University of Iowa.
Okay. Thank you very much. Thank you. Oh, that was fun.